Hi, it is Bible Scribe. The Felix Baumgartner quote space jump uh, was an amazing feat. Felix Baumgartner was carried up to a height of about 24 miles straight up in New Mexico. And from that height, he jumped from the capsule and the balloon he was on and did a free dive, reaching a speed beyond the speed of sound. He broke the sound barrier, and that was really the achievement that was being striven for. That's what he was trying to do. The man who had previously held that record was Joseph Kittinger, and he set that record in 1960. But this jump has been touted by many as a continuing proof of a globe cosmological model of the Earth. And so what we're going to do in this video is really take a long, hard look at this jump and what happened and why the prevailing view is that it somehow proves that the Earth is a globe. So there's a few things that you probably see in this video that you will have never seen before about this jump, and some conclusions that we can draw about many of the so-called proofs of high altitude photos and videos of curvature of the Earth. So stick with me. This is going to be an interesting ride. Thank you for joining me today. First, let's just look at a few snapshots of this video so you get an idea of what happened during this jump.
Okay, Joe, I'm ready.
There it is. There's the world out there. Release the helmet tie-down strap.
Release the tree. What I can see. Sometimes you have to get up really high. The smaller you are. I'm going home now. Roger.
Felix, you calling me?
I'm reading.
Can anybody understand him?
Showing Felix in a stable descent.
1 minute and 30 seconds, and stable as a rock. Felix, you're really stable. You've fallen 3.5 minutes. Four minutes free fall.
I'm pulling my parachute. And
And we had a good shoot on Felix at 8,000 feet.
you decline.
And Felix is back to Earth safely, the new world record holder.
Now that you've seen a quick overview of the space jump here of Felix Baumgartner, let's start taking a look at some of the details of this video, some of the things that, of course, are argued about in regards to the curvature of the Earth. So what we're first going to do is go back into the video and look at a few places where this supposed curvature is shown and take a look. Now here's about the first shot that you're going to see in this video of the, quote, horizon line of the Earth. And you can see in this photo that there's really no curve here to be seen. If I take a pen and then just draw a horizon line exactly where this horizon is, you can see that that line is very straight. There's really no curve being displayed in this shot. So we need to recognize that this camera apparently is mounted to Felix Baumgartner's helmet, and from what we can see from that, with his view out of the capsule, we see a view in which the horizon looks completely straight. So just note that, and we have to keep all these things in our head as we move through the video to really get a picture of what's going on here. So here now in this shot, it's very interesting. As he is starting to climb out onto the ledge of the capsule that he's going to jump from, the capsule, of course, suspended by this balloon, this high altitude balloon. In this shot, you see the horizon line, as you can tell, and it's very curved. Okay, very curved. We have now two visuals from the same camera, one with a very flat horizon, one with a very curved horizon. And I'll just say, because of my experience in photography, and as many people know this, but this seems to be at this point the effects of a wide angle lens, a very wide angle lens. And if you've messed with GoPro cameras very much, you know that especially when this video was made, the original GoPro cameras were all very wide angle lenses on those cameras. So it makes sense that that's what we would be seeing. This curve in this shot is very pronounced, and it's towards the, you notice it's towards the edge of the frame. And that's exactly the effect that a wide angle lens has. As things get further out from the middle of the frame towards the edges, they become more and more distorted by that very curved lens, because that's exactly how they get that effect. The lens itself is curved at a high degree, so that the light coming in, more light comes in from the sides, and that of course distorts the entire picture. So that's what we seem to be seeing here. Now let's go to another shot and see if this now postulate on our part that this use of the wide angle lens is severely changing that horizon line as time goes on in this video. So here's another shot, And you notice in this shot as I'm scrubbing through that the horizon changes as the angle of the camera changes in regard to the horizon, right? So when the angle is higher, the horizon line is curved downward. It's concave. So the problem with the people that argue that this is evidence or a view of the curvature of the Earth, they have no real good way to prove that based on the imagery here, because it's all coming out of this wide angle lens photography that is perturbing, is deforming that horizon line. And even of course, a flat line, a flat plane, a flat anything would be distorted by a wide angle lens in this exact way. You can see this in, for instance, lots of sports videos, because they tend to use wide angle lenses, for instance, with skateboarding videos, and all the hard lines and angles are very curved in those videos. And so that's what we're seeing in this case. But you can see that horizon deforming. And so that's how you know this is due to the optics involved with the camera lens. And it has nothing to do with the shape or the lack of shape of that horizon line. But you can see how that thing just bulges right up because it's getting nearer to the limits of that lens, the edges of the frame, and it bulges right up and looks like a ball in the end. Now, by the way, the curvature is not the only aspect of this that we're going to investigate. So this is only the beginning. In the end, we're going to go somewhere and show you a little more about this particular location, about what you're seeing, that will help you understand the difference between the possibility of this showing anything about the cosmology of the Earth and what Felix Baumgartner's view of it actually was. So as we continue through the video, you know, there's another angle where the camera is pushing that horizon line toward the outer edges of the frame, and it of course goes concave, you know, against the arguments of a globe mentality, because that would negate, of course, their arguments that this is the curvature of the Earth if it was able to curve backwards, you know, concave. And then this view is another amazing view. You notice how in some of these views, I'll try to get this up in your frame fuller so you can see the whole thing. If you see, this curve is so pronounced that it seems to make almost an entire 360-degree circuit within the frame itself. And in fact, you could do this easily if you had the right wide-angle lens and the right subject. You could get the entire subject of the shot to become a complete sphere very easily with a wide-angle lens, because that's the nature of that lens shape. It does that and makes that deformation on its objects. But this, again, just a very pronounced curve. To assume that this is the curvature of the entire globe Earth would mean that Felix Baumgartner, in his view, without a camera, would have been able to see the whole Earth. And we're going to further examine that in just a second as to how that's really impossible. But again, as you see through this video, you just see many different shapes of that horizon line. Very curved to flat to concave. There's another, let's see. There's another view of it being concave. And so this is definitely, at minimum, this is a horrible way for anyone with a globe cosmology to prove that, to pretend that this is a proof of the cosmological shape of the Earth in any fashion whatsoever. It's a terrible instrument for measuring that, is this wide angle lens. So we cannot do it. It's impossible. And we get many different curve lines, many different horizons throughout the video. All right. So that's really about the curvature aspect. The wide angle lens makes it impossible to know that the real shape of what we're seeing in this video, in the photos, and at all. So let's move on then towards the next aspect of what might be interesting about this video in regards to the cosmology, or the view that Felix Baumgartner has from his 24-mile high balloon ascent. So one of the things I did when I was thinking about this video is I wanted to know the specific coordinates of where Felix Baumgartner took off for this journey, because what I wanted to do was look at the land. When you're looking at some shots in this video, for instance, where he sees a view that looks like he's seeing most of the Earth because of the curvature in that frame, I had to ask myself, well, what am I really seeing here? If this is, quote unquote, the curvature of the globe, then in this shot, you know, we have this big circular shape, and what we should see in the areas of the globe that we can see here is we should see a very large, a very vast portion of the Earth itself. But what we really are seeing here, it looks like, are very specific land formations. For instance, this area right here is a very distinct formation on the land surface based on the color of the soil in those areas. This area right here is identifiable. And so instances like this of things that we can identify, what I wanted to do was go and see if I could, on a GPS coordinate map, identify those areas, because we know the location that he took off from. So that's what we're going to do in this section, is start looking at what is he seeing in these frames when he is falling above the Earth at 24 miles. What is it he's seeing? Because we have already identified that this curve may not be accurate, and in most cases is likely not accurate. So that would beg the question, what are we seeing in this area of the Earth that is visible? So if we look and we simply go to the Wikipedia page on this Red Bull Stratos high altitude skydiving jump by Felix Baumgartner on the 14th of October 2012, it's nice that it actually does give us the coordinates of the launch site right here. So what I was able to do was go ahead and look those coordinates up. And so what you can see here, you can easily see that this marker in New Mexico is where he took off from, where they launched him from the Roswell, New Mexico Air Center. And so in the video where we see the balloon being prepped on a launch pad and launched, then we know exactly where this occurred. It was in this Roswell Air Center in New Mexico, and right on one of these landing strips. And so that's what happened. That's where he started. And if we back out here, we zoom out, you can see the area that he landed in is actually on this map too. It's very close. As you can see, it's over here to the right, near Cap Rock, New Mexico. So he didn't drift very far in this thing. You can see near Roswell is where he took off on the left side there. Try to get a little closer if I can. It's hard to get the right zoom on that, but you get the picture here. That marker is where he takes off. He floats to the east here a little bit, and then over here I'll just mark it with an X. He landed about right there, okay, over on the right. So the interesting thing is too here, let's look at the one other aspect of this. The distance is important, I think. So if we do the distance between these 2 points, it says that this distance is about 42 miles. Okay, the distance between his takeoff and his landing is 42 miles. So that's going to become more important in a minute. But this will help us now, because if there are identifying features on the land below him in the video, then we can probably start to map those to those features, find them on the map, find where they are, and then start measuring distances to see how much of the land Felix Baumgartner is actually seeing from his vantage point. So we're going to do that next and look in the video, see if we can find some identifying features and then map them to where they are on the map. So if we first go to about this spot right here, this is supposedly a shot on the ascent where he's, going up, attached to the balloon. It's floating up and taking him with it up to his 24-mile marker. And we already see these, again, as I mentioned before, these identifying features, particularly over here on your left. This and this whole area is very identifiable on a map. So what we can do now is we'll go right back to our map, and we'll look at this. Do you see? This is that identifiable feature that we see in the video. You see there's the two big dots with one kind of in between and then one off to the side, one fuzzier, one below. And when we go to the map, we see exactly that formation. It even is in the same orientation, meaning that this shot from the capsule that he takes at this point from the 1 minute 15 second mark is specifically in a north-south orientation. So this matches perfectly. You can see side by side right there that it's a perfect match. So you know this is where his shot is, where he is above. He is above that area at that exact moment. So now that we can start identifying features, we're going to be able to see how much of the Earth that Felix is able to see at different points in his flight. So let's go to the next spot. Here, just a few seconds later in the video, you see a higher shot of the capsule. So this is definitely a shot from a GoPro camera on a boom outside the capsule. So there's a pole, a boom sticking out from the capsule that has the GoPro on it to give this view of the capsule and whatever is out in the distance. So here you can see on the ground, we don't see those same white spots in this shot, but we do have some other identifying features. For instance, over here, you see some kind of greenish areas. It looks like maybe some pattern going on there. And then we have this long running kind of indentation or coloration that runs through it as like a river or something. And so what we'll do now is go straight to our map and start looking for that. And what we do when we zoom out here and look around, it seems that the discoloration, the river, so to speak, that I mentioned is this river right here. Let's see if we get the name of that river. The Pecos River. And as we zoom back out, you can see that it seems to be a match. All these green agricultural farms seem to match the spots we saw on the video, as you can see right there in the distance. So this is Roswell, New Mexico, essentially, the area of Roswell, New Mexico, from where they took off, really. But that's the agriculture area outside of Roswell, and then this is the Pecos River going up here. So you start to see now how far away he can see, and essentially how far away he cannot see. So for us to assume that, the horizon out here is the far reaches of the Earth is simply not true. It's simply not true. And we can also see, by the way, when we go back to the map and we see the distance, we already know that he seemed to quickly be over this area to the kind of right here where we have these markers with these different ground formations. And so we know he's probably in that area. That's where he landed. He landed right over here. So we can again measure the distance. So the distance is very important. Is very important to this discussion on what he is seeing on his horizon in the views he has, what he can see from where he is. And again, this measurement from where he is floating in this shot right here to what he sees over here. So what we're doing is again, we're measuring the distance essentially from underneath his capsule directly to what he can see, which is he can see Roswell, New Mexico right there. That distance, according to our map, is 41.3 miles. So you start to get a picture now of how far he can see. If this is 41 miles, then how far is this? That's the question we need to be asking ourselves, because it would be important to know from his vantage point at 24 miles high, what's the maximum distance that he can see to the horizon? Because I would assume, based on what we're starting to see, it's a lot less than the, quote, globe Earth people would say it is. They're saying he is seeing the edge of the horizon over the curve of the Earth, and that is why there is a curve in this view. And there's a lot of those arguments that just will not hold water anymore once we discover how far is he actually seeing based on the geography of what's underneath his feet. So let's go to the next area. All right, now in this shot, again, it's one of these shots where we can see a huge curve, and the globe cosmology people will say that's the curve of the Earth, you know. And again, we kind of debunked that based on the wide angle lens changing the shape of the horizon in many of these different shots. But now we have a new tool, and that new tool is what are the topological geographical features that he's seeing. For instance, this kind of run of greenery, and then in the background this darker band of color of green, trees, forest, whatever this is. Can we find this now on the map? And you'll notice right near his foot down here, we see the edges of that white, those white spots that are that very identifiable formation that we've seen before. So now, armed with our new tools, we go back to our map and we say, seems to be, this is our formation as we've always been kind of anchoring to, these white spots near the Cap Rock area in New Mexico. And then west of that, of course, we do see the greenery of the New Mexico, the Roswell area and all the different agricultural farms that are in that area and south of Roswell. And then what we need to find, though, is as this shot shows us, we seem to see that, but then there's another band of color way out here. And so let's look for that. What would that be? So if we zoom out a little bit, we do see that if you go further west, you see this mountain range in the Mescalero Reservation in New Mexico. This is the Lincoln National Forest. And so there's a very distinct mountain range starting from Felix Baumgartner's position, which is right here. He's now looking to the west. He's seeing Roswell and the agricultural space there, and then he's seen beyond that to this mountain range in the Mescalero Reservation, including Sierra Blanca Peak, the Lincoln National Forest. That's exactly seems to be a good candidate for what's in the shot. So going back to the shot, that's exactly what we seem to see. We see from east to west, we see the white markings that are directly below him. We see Roswell, New Mexico and its agricultural centers. And then in the distance, we see the Mescalero Reservation and the mountain range there. So now we know exactly what we're looking at. Again, we can test the distance. So we'll go back to our map and we will check the distance between Cap Rock and the mountain range that he is seeing now. And it appears that that's 113 miles. So if we go back to our video and we mark that from essentially this area underneath him straight to the mountain range, this is 113 miles. 113 miles. There's no question. We don't have to wonder what this is. So he's seeing essentially 113 miles, and then a very short distance after that, he sees a horizon. So I would estimate that beyond about 200 miles, he's not seeing anything. That seems to be the limits of his distance. Perhaps 200, I might be being generous with that. It might be a lot less. It might be about 150 miles. Let's cut the difference and say it's 170 miles. So this would give us the indication that Felix Baumgartner, from his vantage point, regardless of whether he's using optics or his naked eye, he can only see 170 miles away in any direction. Does that change a little bit of the picture of what your view would be like if you were able to travel to that height? So this is what we need to think about. Are any of these videos, like this one or other rocketry videos or high altitude balloon videos, are any of them capable of proving the shape of the Earth? And we can see from what is visible that the visibility range for looking and viewing the Earth from this type of vantage point is very limited. You would think from the height that he's at, he would be able to see hundreds of miles, but he cannot. His range is occluded, and at some point there's a drop off, and it seems to be at about the 150 to 200 mile mark in any direction. If he turns around, he can see 150 or 200 miles in the other direction, but no further. And so this is an interesting observation that this is what the view looks like from up there with your naked eye. This is how it is. This is how it always is. And of course, the nature of that view is interpreted by people who have a specific cosmological view. So globe earthers interpret that view as a sphere, and flat earthers interpret it as a flat plane that, of course, shows as much of the Earth as you can see. Now, of course, I have my opinions, and I float towards that view. I definitely believe that it is not proving in any way a spherical cosmology. There's nothing about this that says sphere to me. And as you can see in this other view, it's very similar to what we just saw. You see the white outcropping, you see Roswell, New Mexico, and you see the mountain range. And then just beyond that, you'll see the horizon. Again, reiterating the fact that he can see about 150 miles, and that's it. That's as far as he can see in any direction. Now in this shot again, you can see it's our white markings as he's now on his free fall. We see the white markings. Roswell is kind of hidden behind his arm and his body here, and then we have the mountain range in the back, and of course we have the horizon just beyond that. Now in this shot seems to be a different view of the area, but we can find a few things that help us, and that specifically is this little, I think it's a body of water, it's a little dark area, and this lighter area. So when we take our map and we look for those things, what we find is that right here to just the northeast of his landing site, we find those same two features. And so we can make an easy match there, just that he's turned around, and in his camera you can now see northeast, and that's what you're looking at here. And then his landing site, his final landing site is about here, is about where he ends up, just so you're aware there. And then here in this shot, again, we see our white features down here. He's getting closer and closer to the ground. Now you see that the sky has turned blue again. That's a very interesting phenomenon. It seems to be, and I'm not sure at which altitude that occurs. I suppose we could find it on the video here where that changes, but it goes from feeling blue and looking blue in your field of view to then looking black, completely black. And so there is a point at which that changes, and he is now below that point. But as you can see here, there's just not that much distance to the horizon. This feature is only about 10, 15 miles away from him. So the horizon being here, again, now in his field of view, we can't barely even see Roswell, New Mexico, which is probably in this area. And the mountain range is probably just back here. But again, it's so close to that horizon. There's no distance here. He is just not seeing very far. So as he's gotten closer now, his vision is more occluded to the point where he probably can only see about, I would say, 60 miles or so here, maybe 70. So it seems to be very occluded. And even though you can get to these high altitude positions, 24 miles or whatever it is, you still have a very limited vision due to possibly atmosphere and other variables. And it's just not, you're not able to see the quote whole Earth when you're at these distances. And so there's no way that it proves any kind of cosmology. Particularly, it does not prove a globe cosmology, but seems to lend itself more towards a flat cosmology for the Earth. So now that we've looked at the different aspects of the video and what we can gather from the way they used camera lenses to make certain things appear a certain way, and perhaps that was not necessarily intentional. Let's give them the benefit of the doubt, but because they use these GoPro wide-angle lens cameras, and because of what Baumgartner can actually see when he's that high, we have now a better idea of what it looks like up there and what you can see and what you can't see when you're that high. And so now that we have all this information, what I wanted to do was kind of play with it a little bit. And so what I did was, knowing that, this area is where Baumgartner was above, what I've done is I've taken this and done some experimentation with it. So what I did was I took it into a three-dimensional graphics program. So what you see in front of you, if you can tell from the screen, you can see there's a square right there. And so what I've done is just create a plane, a flat plane geometry. And you can see that it's there. It looks like a square. And so this is where my surface I'm going to play with as far as trying to visualize what it looks like to be that high, what Baumgartner saw when he was 24 miles high in the sky. So not only can I create this plane, but I can also map onto it what it looks like Baumgartner saw from the capsule at 24 miles high. So when I map that texture onto this plane, this flat surface, you can see this is the specific area, and right in the middle you can see Roswell, New Mexico, and those different agricultural areas, the farmland. And so when you back out, you can see again those mountain ranges on the left from the national park in that area. And so the whole area is here. Just to be more specific, he took off from New Mexico, or from Roswell, New Mexico, right here. He landed over in this area, And of course, in the view, the whole time we saw this whole area in the frame of view. This is about the limits of what we saw in the video. And so as I take that and I can map it now like this onto a flat plane surface, and then I can also zoom in and I can pretend that I am flying above this surface. So you can see kind of how this starts to look and feel. And you can see why if your vision is occluded and you're 24 miles high, it might appear to you that you were looking at the curve of the Earth. But the reality is that that's not necessarily what is being seen. If it's the limits of your vision in a radial formation, so if I can only see 150 miles or so in each direction, then this is how that looks. And it's very simple to do this kind of simulation. So you can tell that anyone going up this high, because their field of view is limited to about 150 miles, they might, if they had the perspective of a globe cosmology of the Earth, they might think that they were seeing the curve of the Earth at this height. But what they're really seeing is only 150 miles of distance, and then their vision is occluded. It drops off. They cannot see any further. So again, as we have stated before, this video and the views that we get from Felix Baumgartner, where he sees Roswell, New Mexico in the foreground, and he sees the mountain ranges of the national park in the background, and then he sees the horizon, he still can only see around 150 miles in any direction. And this is exactly the view he gets. And just again, note that I mapped this view of the surrounding area that he took off and landed in. I mapped it to a flat planar surface. As you can see when we back out, this is a completely flat surface. And so this lends credence to the idea that Felix Baumgartner could have been seeing the flat Earth, the flat plane of the Earth, from the distance of 24 miles high, and that in any direction he looked, it would have seemed like he might have been seeing the curve of the Earth on the horizon. That might have been his perception because of his own preconceived notions of the shape of the Earth. Now there's one other thing we can do. I also went ahead and added to this scene in the sky above this flat plane that I created. As you can see, that little tool handle there, that is my camera that I added to this scene. And so I was able to add it at a 24-mile distance from this surface. And what I can do is I can allow us to look through that camera. And by the way, I also set this camera at a very wide angle. It's set at a 14 millimeter lens, which is a very wide angle lens like is used on the GoPro cameras. And so I'll change my view now to that camera. And the rectangle, the yellow rectangle outlined, is what the camera sees. But you can see the deformation of the entire surface that I have and why it looks curved now. It looks very distorted, especially around the edges. And as we can do this type of thing, we can change the orientation of this camera to either go side to side, or we can go up and down. And as you do that, you can see how the curve seems to change. And as it gets towards the top of the frame there, just like in our video, that curve is very pronounced. It looks very round there. It looks like, oh, it looks like a ball. And then we get down towards the bottom of the frame. It seems to flatten out a bit. Now, be aware that this computer program is an approximation of the lens. There's mathematics used to approximate the wide angle lens. So it doesn't quite flatten out like the lens in the video. And because of the video, it gets even more flat and even concave. It goes inverted. And that doesn't happen here because this is an approximated mathematics that tries to simulate that lens. But you can see how deformed things get when you're using this wide angle type lens, and you can also see how it seems to make sense that that wide angle lens would create the kind of views we see in the Felix Baumgartner video, again with a flat surface and a simple idea of the radius of the focal length, the field of view of the viewer being limited to about 150 miles when they're 24 miles high. So again, that seems to put in perspective what we see in the Felix Baumgartner video, and that, you know, it may not be exactly what globe earthers, people that follow a globe earth cosmology, say it is. And it definitely is not proof of their case in any sense. Whereas we've been able to simulate now with a very flat surface, a flat plane, we've been able to simulate everything that you saw in that video. So I hope this is eye-opening for you. It gives you a new perspective on what may or may not be happening in the case of videos like Felix Baumgartner's and other high-altitude balloons and rocket videos. You just aren't getting a very clear picture of what is being seen. But based on our research in this video, it seems to be that we can approximate very easily what Felix Baumgartner or anyone else at that altitude would see as far as the horizon is concerned. And it may appear to some people that it was a curved horizon simply because of the fact that their field of view is limited. And it always is this way. So I hope this gives you a new perspective, gives you some food for thought, helps you consider what we might actually be able to see or not to see when we're at these kinds of altitudes. And it might give you a new perspective on the cosmology of our own Earth. Thank you for your time, and take care.